I'll be doing group work 9. This problem states the residents of Springfield have long suspected that radiation from nuclear power plant is increasing the length of pregnancies in their town. After doing some research, Professor Frink determines that a good estimate of the mean length of pregnancies nationwide is 282.5 days, with a standard deviation of 10.5 days. The average length of the last 36 pregnancies in Springfield was 290 days. Sub-question A is asking, if the lengths of pregnancies in Springfield follow the national trends, what are the mean and standard deviations of the mean length for a random sample of 36 Springfield pregnancies? Okay, so we already know so in this problem we know that the mean is 282.5. Our standard deviation is 10.5. Our sample size is 36, and the value that we're using is 290. So in this case, we already know our mean, which is 282.5. The only thing that we need to do for A is we need to find a standard deviation of our sample population. So in this case, we would use the equation, our population standard deviation, which is 10.5, and we divide that by the square root of n, our sample size, which is 36. And as you can see, it will equal our standard deviation of our sample population is 1.75. For B, if the length of pregnancies in Springfield follow the national trends, what is the probability that the mean length of a random sample of 36 pregnancies would be 290 days or longer? So in this case, we would need to find a z-score whenever it asks for probability. So as you can see, the z-score equation is up there. Z-score is equal to the value minus the mean divided by the standard deviation. So z is equal to 290 minus 282.5, divide that by 1.75, which is equal to 4.49. And if we look on our z-score table, 4.49 is actually greater than 3.89, so our probability is actually equal to 1. C is asking, does your answer in part B suggest that pregnancies in Springfield are longer than they should be, or did the last 36 women just get a little unlucky due to random variability in pregnancy length? In this case, they were unlucky because the sample is too small to tell. In part D is asking, if the lengths of pregnancies in Springfield follow the national trends, what length would represent the cutoff for the longest 5% of all pregnancies? So in this case, we would take 5, divide that by 100 to get equals to 0.05. And here we are trying to find a z-score. So in order to find a cutoff, we would minus that from 1, so 1 minus 0.05, which equals to 0.95. Then we would find a z-score, the z-score that is close to 0.95, closest to 0.95. In this case, the z-score is 1.65. Then we need to find what the cutoff days are, or day is. And from there, as before, we just use simple math, simple algebra. We already have our z-score, so 1.65 is equal to x minus 282.5, divide that by 1.75, and we times each side by 1.75 to get 2.8875, which is equal to x. Equals x minus 282.5, and we add 282.5 to each side, and we get a value of x which is equal to 285.38. So the cutoff for the longest 5% is about 285 days.